Welcome to Chibuzor Mathphysics. Let's consider the third question. This should be part 4 of this video. So you need to watch the previous videos in order to know how we dealt with those questions. So let's take this question. A pair of coin or a fair coin is tossed repeatedly until either it lands heads or total of 5 tosses have been made. Whichever comes first, let x denote the number of tosses made. So we are to find the first question here. We are to determine the probability distribution of x. So let's do that. Another way we can say that to determine the probability distribution of x, they are simply asking us to construct the probability distribution of x. So let's have the solution. First of all, we need to take the sample space. We need to have toss a fair coin is tossed repeatedly, so we are going to toss the coin. Let's do that. So let's use this wider place. Let's say that the sample space it has to be tossed repeatedly until either it lands heads or a total of 5 tosses. So it must be up to 5 tosses. So when you toss a coin first, if you toss a coin, you will first of all, let's assume it will have the head. This is the first toss. If you toss the second time, you can either get the tail or the head. Toss it again, you will have tail, and then you have head. If you toast again, you will have tail, then you have the head. This is 1, 2, 3, 4. But remember, we are going to toast 5 times. We are going to toast 5 times. So let us do it again. If we toast again, we simply have tail, head. This is 1, 2, 3, 4, 5. Let's toss it again, because now we are still having head. We are going to have tail. That is 5 times. So at this point we will stop, because it has to be total of 5 tosses. So let's say that the number of our sample space as it is here is equals to 1, this is 2, 3, 4, 5, and 6. So the number is 6. Here x, we know that x represent the number of tosses. But we know from the question that x is equal to 5 tosses. So we have 1, 2, 3, 4, 5. Let's use the information we have now to construct the probability distribution table of x. We simply have our x, and then we have our probability of x. X will take the form of 1, 2, 3, 4, 5. But remember, we got the 5 tosses when it is 6. So 1, 2, 3, 4, 5. Then we have 6 here. So this we have 6. When it is 1, it will be 1 over 6 because we know it is a total of, the sample space is 6. So all this will be 1 over 6. So here we are, and we've succeeded in constructing the probability distribution table of X, and that answers the first question. Of course, if you want to determine X proper, you might need to find the expected value of X, and to do that, you know, a expected value is just the summation of this plus that. So you take X multiplied by probability of X plus 2 multiplied by probability when X is 2 plus you take 3 multiplied by 1 over 6 plus 4 multiplied by 1 over 6 plus 5 multiplied by 1 over 6 plus 6 multiplied by 1 over 6, and that will be the expected value of X, in case you want to do that. So let us now look at the next question. We are to find the probability of X less than equal to 3. So we are looking at the probability. This is B. Probability of X less than equal to 3. Less than equal to 3. This would be the probability. When it is less than equal to 3, it means that we are taking the probability is less. So X is equal to 1 plus probability X is equal to 2 plus the probability X is equal to 3. And we know that when it is equal to 1, it is 1 over 6 plus 1 over 6 and plus 1 over 6, because all these are 1 over 6, and we will simply get 3 over 6, which is a half. That is our probability, which will also give you 0.5. Good. So now let us take the next question in this. Let's take the next problem in this question. So the next question says that we take the probability of 2 is less than X less than 6. So this is option C. The probability of 2 less than X less than 6. It simply means that 2 is not included because it's not less than equal to 2. It is simply less than 2. So we are taking the probability when X is equal to 3, because it's less than 2, which starts from 3, plus the probability when X is equal to 4. We take the probability when X is equal to 5. Equal to 5. This is 3. 6 is not included because we are taking the probability when X is less than 2 and also less than 6. And what is less than 6 is 5. So 5, 6 itself is not included. And we know from our table that the probability when X is equal to 3 is 1 over 6. Plus when it is equal to 4 is also 1 over 6. And when it is 5, it is also 1 over 6. So if we take this, we will simply also get a half 1/2, which will give you 0.5 as well. So this is our solution to this question. In the next video, we shall be handling the last question in this series of probability and statistics. Enjoy it, and don't forget to put in your comment on the comment section below, and your feedback. Subscribe to the channel if you are new, and do well to like